Hi, I'm Emily Eckman, and this is my Unit 4 project for Anatomy and Physiology 1. So, the first subject I wanted to go over is the cardiac conduction system. This is important because the heart is the only organ that works independently from the rest of the body, and this is because it has its own conduction system, and therefore it's autorhythmic. So, this whole system starts with the sinoatrial or SA node, and this is known as the pacemaker of the heart. The SA node controls heartbeat and is the main gateway of electricity in the heart. So the heartbeat actually makes a lub-dub noise. That's how it's described because the right side contracts and then the left side. So when you listen to the heartbeat, it goes lub-dub, lub-dub. And the contractions go from right to left in a semi-twisting motion, and this helps move the blood through the heart. This electrical signal passes from cell to cell using gap function. So the path of conduction in the heart starts with the SA node. So the SA node fires, and then the electrical excitability spreads through the atrial myocardium. Then the atrioventricular or AV node fires, and that initiates the contraction of the ventricles. So then the energy is spread by the atrioventricular bundle. This is also known as the bundle of His. Finally, the Purkinje fibers dispense the rest of electricity through the ventricular myocardium. And this whole system is how the blood moves through the heart. The second subject I chose to talk about are veins. So the main points about veins are that they contain a majority of the body's blood capacity, which is actually 54% are in the veins. The veins are responsible for bringing deoxygenated or less oxygenated blood from the extremities back to the heart, and they transfer the blood through a valve system called venous return. Veins are actually also known as capacitance vessels, and unlike arteries, they don't have a muscular wall, so they can't support themselves. If they weren't full of blood, then they would flatten because they don't have the thick muscular walls. And another part about veins is venous return, and this is how they move blood through the body. So pressure gradients are mainly responsible for venous return. Some other aspects that go into it are gravity and the use of valves. So gravity is responsible for bringing blood back from the head and the neck, and skeletal muscle and thoracic valves work by compression and pressure. So when we move and work out, our muscles contract and release, and this helps bring the blood back to the heart. And the thoracic valves work through inhalation and exhalation. So when we inhale, the space increases from the air, and then when we exhale, it compresses again. So more blood flow happens when we inhale. And venous return increases when we exercise, and it pools when there's inactivity because we don't have the skeletal muscle contracting. This is interesting because some of the new methods of CPR only instruct the care provider to do compressions and not the breaths, because this keeps oxygen in the body and keeps the blood flowing. And yeah, so there is a general overview of veins in the cardiac conduction system.